right, 12.5, volume of pyramids and cones. So we're going to use the volume of a prism formula to figure out what the volume of a pyramid formula is. So how can we do that? Let's see if we can do some comparison. If I have a prism and I have a cone and they have the same height, and the same shaped base, how do their volumes compare? Well, a good way to think about this is how many times, how many of these pyramids would fill this prism? Take a guess. How many pyramids do you think would fill this prism? If I tried to stuff as many of these pyramids into this prism as I could, how many would fit? Or even better, what if I filled this with water, the pyramid, and poured it into the empty prism? How many of the pyramids would fit? Take a guess. Well, let's take a look at a video to see how your guess compared. Normally, I would do this myself with my toys, but since I'm not there, I just found this person to do it for you. Let's see. So they started off filling the first prism with water from the pyramid. Notice they're the same height, and I promise you they're the same shaped base. Here comes the second one. Pretty good. Pour it in. Excellent. No spills, and we still got some space, so it's more than two. Let's see. Yep, perfect. Three pyramids fill the prism. So how can we use that to come up with a formula? Well, it should be pretty basic now. If I have the same base, the same height, I just got to multiply the prism volume by a third. 1/3 the volume of the prism will give me the volume of a pyramid that has the same height and shape base. So there's your formula, 1/3 area of the base times the height. Here's some other visuals to show you. I talked about how many pyramids would fit in the prism. Well, of course, you have to move around the volume. You can't just keep them all with a vertex right over the base and expect them to lock together. But if you rearrange them so their vertices are not all lined right up, the same volume taken up though, same space taken up, you can fold those three right together to make one prism with the same height and shape base. So it's just 1/3 area of the base times the height, and the cone works the same way. A cone's just like a pyramid. It's 1/3 area of the base times the height, just like the cone compares to the cylinder the same way the pyramid compares to the prism. And they're showing you basically the water test again, just electronically. 3. So it's 1/3 to find the area of, or the volume of the prism. So now we can just do a bunch of example. Let's find the volume. I'll let you try this first one. Let's see how you did. Volume would be 1/3 area of the base times the height. Since this is a triangular pyramid and I see the right triangular base, I'll do 1/3. Then I can do half base times height to find the area of the triangle. I'm going to multiply that by the height of the pyramid, which is 9. And I guess I should have just done the half base times height. Half times 4 times 6. This would be, let's see. Ooh, I just changed this third to a half. I better fix that. I'll fix it there too. Sorry. Uh, so this is 12 times a third is 4 times 9 is 36 meters cubed. Don't forget the area of the base is units squared. The height is units. And when I multiply them, I get cubic units. Just double checking on my math there. 12 times a third times 9. Perfect. Hopefully you got 36 cubic meters as well. And for this one, we do 1/3 area of the base, which is of course a circle. So it'd be pi times the radius squared, squared, 2.2 squared inside, times the height of 4.5. I'll tell you right now, a third of 4.5 is 1.5. But then I have to do the 2.2 squared times pi. So 2.2 squared is 4.84. 4.84 pi. And if I multiply that by 1.5, I get 7.26 pi cubic centimeters. This would be exact. And then if I asked you to round, of course, you can make the pi into 3.14 and get like about 22.8 approximately 22.8 centimeters, cubic centimeters. So hopefully you're getting the idea. Let's see what else we got. This one, it says originally the pyramid had a height of 144 meters and a volume of 2,226,450 cubic meters. Find the side length of the square base. All right, well, volume equals area of the base times the height. Don't forget over 3 or times a third. So the volume they gave us is 2,226,450. And that equals 1/3. The area of the base, which if it's a square, I could just call the sides x and say x squared times the height, which was 144. And what we can do is, well, we could do 1/3 of 144 and get 48. And then divide the 48 over 2,226,450 divided by 48. And now I'm getting some beautiful decimal. 46,384.375. Should I double check myself there? 2,226,450 divided by 48. 46,384.375, and then I'm going to square root that, and I'm getting 215 point. And they are asking for the side length. They didn't give me rounding directions. I got a whole long decimal. I'm going to round it to the nearest tenths. I got 3.7, but I'm going to round it to 4 for the side length. And now I got to get it's meters, 215.4 meters. And that would be a good side length. Hopefully you got that too. Let's see, should we choose ones of these? All right, let's try this one. Hexagonal pyramid. Let's round. Let's give an exact answer and round. Try number 1 on your own right here. Yeah, let's see how you did. I'm just gonna give myself some space. So it's a pyramid, so I'm gonna do 1/3 area of the base times the height. The height's 11, it appears. I got 1/3, of course, and now I gotta find the area of my hexagonal base. Hopefully you've done enough hexagons to be able to kind of plow through these quickly. If the side length's 4, you can draw your central angle in, 360 divided by 6, which is 60. Cut that in half with your apothem, there's your 30, and you get the half side, and then the half side √3 right there is your apothem. I'm going to do half times the apothem of 2 √3 times the perimeter of 24. Am I squeezing too much there? And I have half of 2 √3 is √3 times 24, which was the perimeter, and I get 24 √3 for the area of my base. And then I'll do it times 1/3 times 11. 8 √3 times 11 is 88 √3, and this is cubic yards. And it says to give an exact and rounded, so I'm going to do 88 √3 into my calculator, and I'll say that one's approximately 152 point. What did it say? 2 decimal places? 42. 152.42. Hopefully you came up with that. Let's see what else we've got here. Number 2 here, it said to find the volume of this right cone. Let's knock this one out quickly as well. It's just 1/3 area of the base times the height, right? So 1/3 area of the base is 25 pi. The height I don't have. They gave me the slant height here. So I'm going to do 64 minus 25 because the radius squared plus the height squared equals the apothem squared. So I'm going to do the height squared equals 81 minus 25 square rooted. So the square root of 56, I believe I just got. And then 4 goes into 56, right? So 2 √14 is my height. 2 √14, because 4 times 14 is 56, right? And 81 minus 25. Sorry, I'm just double checking everything. Oh, mistake. Back it up, back it up, back it up. I very nearly just decided to re-record, but I think I'm going to let it go. You've seen me make mistakes before, so why you check yourself? The radius squared was 25. The height squared equals the slant height squared, first of all. I don't know what I have an A there for, but that slant height is 8 squared, which is 64. So we're doing 64 minus 25, which is 39. So the square root of 39 is what I just got here. And now I'm doing, it says I'm going to start giving it exact first. Here's my exact, 25 pi root 39 over 3. That seems exact. And then I'm going to do 25 divided by 3 times pi times root 39. I just 5 divided by 3 times pi times the square root of 39. About 163.5, actually 49. It's rounded to the nearest 2 decimal places. Boy, this is going to be a good recording, folks. Not starting over. Meters cubed. 25 pi. I'm checking myself again because I'm on a roll of not doing well with these answers. I like it. So there's number 2. And now this last one, the volume of a right cone is 1350 pi, and that's going to equal area of the base times the height. So the area of the base would be 18 squared pi, because that's the radius of 18. I'm going to multiply that by the height. So I'm going to divide by pi, and then I'm going to divide the 18 squared over. 1350 divided by 18 squared. I'm getting approximately 4. So it's round to the nearest. Well, my exact answer would be, I think it's trying to, 18 squared is 324. So it'd be 1350 over 324. 1350 pi over 324 over 324 equals, and then I'm getting 25 pi over 6. That would be exact for my height. And then times pi, which is approximately 13.09, and that would be meters. Whew. Throwing me for a loop there. Let's see what else we got. Find the volume of the right cone. Ooh, I like the 65-degree angle. I'm going to let you try this one. Oh, they give us a little hint there to use trig. Well, I have the height is 16. I need that radius. So volume equals 1/3 area of the base times the height. So the height is 16. I need the area of the base. The area of the base equals pi r squared. I need to get that radius. Well, to solve for the radius, I could use opposite over adjacent. I could use my tangent ratio and say that the tangent ratio of 65 equals 16 over the radius. So the radius would equal 16 over tan 65. I'm going to go get an approximation for that. 16 over tan 65 equals, I'm going to get a radius of approximately, I'm not going to, all right, 7.461. I'm going to round it to the nearest 10/100th thousandths place. I'm going to square that. 55.66. I have a whole long decimal on my screen. I'm going to multiply that by pi. 174.88. I'm going to leave the calculator decimal. Divide by 3 times 16. And I'm getting a volume of 932. No rounding directions. I'll say 0.7 feet cubed. Hopefully you got something similar. And is this the last one? Yeah, last but not least. Oops. Find the volume of this solid. All 6s. Give it a shot. All right, let's see what happened. Well, I can just add the 2 volumes. Volume of the prism plus volume of the pyramid. And I noticed they have the same base and height, so we can talk a little bit about how those volumes are going to compare. The volume of the prism is, well, area of the base, 36 times the height, 6. Volume of the pyramid with that same shape base will be 1/3 of whatever 36 times 6 is, area of the base times the height. So really, this is 1/3 of this. The pyramid's volume is 1/3 of the prism's volume, if you remember back. So I'm doing let's do a third of 36, or a third of 36 is 12 times 6 is 72. And I'm going to take that 72 and I'm going to add the 36 times 6, which is 216. And of course, I end up with 288 meters cubed. Hopefully you came up with that one. All right, some good examples in that lesson. Go try the homework, and I'll see you next time.